Welcome back, my friends. We're going to go over the notes for 7.5, solving equations that involve rational expressions. And so the textbook homework is there. I hope that you're trying some homework. It is really valuable in math. People tell me I don't get math, and usually I look and they don't do their homework. And it really does take struggle to learn math, and so I kind of think that that's partly why, so I mean, STEM, you need all of the math, you need to know the math, but you also need to be able to think. And I think that math builds that thinking. So strategy for solving an equation involving a fraction. And so we've already kind of learned a strategy for solving when it involves a fraction. The first step is to clear the fraction, get rid of it. Then you can solve it like you normally do. And so that's the strategy. And so how you clear the fraction is you first find the common denominator. Then you multiply every term both sides of equals by the common denominator. The reason that's okay is because we had that property, the multiplication property, and they told us that if you have something, A equals B, I'm going to say, and then you multiply both sides by any value, but in this case the lowest common denominator, they would be equivalent equations, meaning they would have the same solution set. And so when you multiply by the lowest common denominator, and then if A had been a binomial, you would need to distribute. Or if it was a trinomial, you'd need to distribute to all, because when you multiply by something, there's the distributive property. So if A is a monomial, then no problem. But if it's a binomial or a trinomial, you need to distribute. Same with B. And then remember that you're here to get rid of the fractions, and so you want to make sure that you do the reducing, the canceling out first, and then the multiplying second. And then solve normally to us means, well, what is it? And so, and we'll be going through that as we go. If it's degree 1, then we learn how to solve in chapter 1, yeah, it was chapter 1, we learned how to solve linear equation. And we said you distribute, you combine like terms on the left side and the right side, you add or subtract, you get the variable on one side and the numbers on the other. And we saying you got to get them separated here. And then you use multiplication and division to isolate the variable. If it's quadratic or higher, degree 2 or higher, and I think your book pretty much focuses on degree 2, then what you got to do is get 0 on one side, factor it, set the pieces equal to 0, and solve. And then here is something that I said to you guys, check. It's a good idea to check. Well, on these, it's not just a good idea to check, it's necessity to check. Because remember that the denominator should not be 0. And when you clear the denominator here, and then you solve it normally, you might get what's called an extraneous solution. Something that solves this here, but didn't solve the original because the denominator was 0. So you want to make sure that you go back and check and make sure that the denominator is not 0. So this is the thoughts on how to solve these. So I would look at this problem, it's asking me to solve, it has an equals in it, and I would be saying to myself, oh, it's fractions, ooh, fractions, fractions. So that's what I would be thinking, oh, fractions. And when you have fractions and you're trying to solve, I say to myself, clear them, get rid of them, right? So you have to find the common denominator. And just a little bit ago in 7.4, we actually had found the common denominator between x and x squared. Do you guys remember what it was? And so I can hear some of you mumbling. Others are looking at their cell phone. And so I'm just joking. Anyway, so the common denominator, right, we built it. We had x, and x squared is equal to x times x. So this says you got to have an x for the lowest common denominator. This one says you got to have 2 x's. Well, I don't have 2 x's, so make another one. Got to have 2 x's. And now it meets both conditions. Got to have 1 x, yes. Got to have 2 x's, yes. And so hot diggity dog, that's the lowest common denominator. Now you could write it as x squared. xx and x squared are exactly the same. And so your choice on that. And then what we're going to do is we're going to multiply both sides of equals by that. And I'm usually too lazy to write this, but I always write it the first time. Oh, I'm going to have to scoot that over a little bit because I didn't leave myself enough room to write it in my talk of how lazy I am. So right here, I'm going to multiply this whole side, which is a binomial, by the common denominator, x squared. And I'm going to multiply this whole side, which is a monomial, by the common denominator, x squared. And so that's that property that we learned all the way back in chapter 1, that what you do to one side when you multiply, you got to do to both sides. But we just haven't had with a binomial before. And so now I'm going to be distributing this, x squared times 2, so x squared times 2, distributing this, and plus x squared times 5 over x equals, on the other side, I'll write it again just because I'm here, and then I'm going to do my simplifying. And so you simplify these pieces, and this is the line I usually write first. I wrote that so that you know, hey, that's the property. And then this is the line I usually start off with. So when I multiply those together, there's no reducing to do, so it's just 2x squared. When I multiply these together, this is x squared over 1, and remember what that is equal to. I'm going to write that over here, that thought. This is x squared, right, is x times x over 1 times 5 over x. And I'm here to reduce, and that x reduces with either one of those x's, it doesn't matter which one, and leaves me an x and a 5 and 1 in the denominator is all I have, and so that's just 5x. So this is plus 5x. And then over here, over 1, right, and I don't have to do that one on its side because it's like perfect, right? X squared with x squared is 3. And now I'm looking at this problem that I have here, and it has the same solutions as this one, other than you should not have anything that makes the denominator of this 0. And so otherwise it would have the same solutions. And so if we get that, if we encounter that, then we'll deal with that. And so I'm on this thing right here, I'm thinking, oh, it's quadratic. Quadratic means, right, degree 2, it's degree 2. And so here's the degree 2, right, x to the second. And what that means, what you do when it's degree 2, is that means to get, there's steps, right, get 0 on one side. So I'm going to get 0 on one side. Step 2 is I'm going to factor it. And then I'm going to set the pieces, which is different than Mises, equal to 0 and solve. Oh, just a second. Doug, it's for you.
Hello?
Sorry, that was an important phone call from, not for me, but for my husband, and he was not here to get it. So -3, I don't know how to back up or edit that out. I would do it if I could. So that's not like terms with the 5x. So I'm getting 0 on one side, so I'm taking away 3. So my plan is to get 0 over here. And those are not like terms, but I'm getting it in order, so that's okay. And then, so we got 0 on one side. Now we're going to factor it. So we're going to whip out our factoring. And so you don't want to get in my video, babe. You didn't, don't worry. And so he could get in the video because he's not as shy as I am, and I'm not getting in the video myself. I'm trying to keep my fingers out of it. I'm surprised I haven't got gloves out. And so here it's got to subtract to give 5, and I can see that 3 times 2 I can make 6, and so that will be good. So x and 2x. And I know I'm going to have to put the 3 and the 1 here, and I told you guys I was planning on making 3 times 2 to make 6, and then x times 1x to make 1, and then 6 take away 1 is the 5, right? And I want it to be positive, so I'm going to have to put a positive here to make the 6 positive, and the negative here to make to take away the 1. So that equals 0. Then what you do is you set your pieces to 0. So that's x plus 3 equals 0, and 2x minus 1 equals 0. And then you solve those. So I'm going to have to take away 3. This is now linear. Degree 1, right? And what you do to solve something that's linear, degree 1, is you get them separated, right? That's the basic thing. And because I don't have any distributive property or any like terms to combine, I got to get them separated. So this is degree 1. That's x to the first. That's x to the first, right? And so taking away 3, I get x equals negative 3. And I'm going to add 1. So this is 2 steps. 2x equals 1, and divide by 2. X equals half. And so my answers are x equals negative 3 and half. And I know I've written all over this paper like a crazy person, and I'm looking for a piece of scratch paper because I'd like to check my answer, and because I wrote all in, how I am, I'm going to have to go on scratch paper to show you that, hey, yeah, it works, and what we're looking for. So I'm whipping out a piece of paper here so that I can check my answer. When you check your answer, you need to check back in the original. So you go back to the original, which was 2 plus 5 over x equals 3 over x squared. And you only check these things one at a time. So I can either check negative 3 first or half first. It doesn't matter. So I'm going to start off checking x equals negative 3. And where I see x, I'm going to put in negative 3. So this is going to look like 2 plus 5 over, and then there's where my x is, equals 3 over negative 3 squared, right? And I'm going to put in negative 3 in those spots. And then your choice on if you do this with your head or if you do this with your calculator or your head, whichever one you want. But I'm going to verify that the left and the right are equal to one another. I see that the denominators are not 0. This denominator is negative 3, and that denominator is actually 9. And so the denominators are not 0. And so that means that if it doesn't equal, I've made a mistake. And so it's not an extraneous solution. It's looking good. So I'm getting my calculator up here, and I'm going to be adding 2 and then plus, and then I want to make the fraction, so the fraction key, and 5, and then I want to go downstairs, and you can put parentheses around the negative 3 if you're just a person that wants to make sure that you make it look exactly the same. You certainly can. And so now I made it look exactly the same as that side. And so this is equal to 1/3. You could have done it with your head too. And then this side over here, you could do this with your calculator or your head. And so if I do it with my head, that's 3 divided by 9, which is 1/3, right? So if I do it with my calculator, I have to put my fraction key, 3, go downstairs, put my parentheses, negative 3 in my parenthesis, and square it, and then I get 1/3. You can always pause the video. So like if you are wanting to check this, but you realize your calculator was someplace else or you went too fast, you could pause, right? So make sure that you're doing a little pausing too. So that one worked. I want to verify also that x equals, and was it positive half? It was positive half, also works. So we're going to have 2 plus 5 over equals 3 and then over squared. And we're going to be plugging in half. And so I want to show you how to put that in your calculator. So 2 plus, and then fraction, and in the numerator 5. And we go in the denominator, and I'm going to put it in just exactly like we see it, parentheses, and then fraction, and in the numerator of the fraction 1, and go downstairs, and the denominator of the fraction 2, I want to go out to the side to end the parenthesis, And now it looks exactly like it looked on the screen. And this is equal to 12. And so I want to verify that this also equals 12. If it doesn't equal 12, then I have made a mistake somewhere. And so we'll try it. So fraction 3, go downstairs, parentheses, and then I want the fraction half. So fraction 1 over 2. Go out to the side to end my parenthesis and square it. And you could use this is the raise to anything you want button, and that's the raise to the second button. I can do this button, and then I have to type in a 2. And that's helpful when I wanted a 3, right? And so it worked. So both of them are good answers, right? So I can go on to the next problem. So we did a lovely job on that. Okay, so that was problem 14. This is problem 15. Oh my gosh, problem 44 down there. Oh, do only one. Oh my goodness. What do I do about do only one? Okay, so what was I thinking, right? I was probably thinking that I'd let you guys choose, knowing me, so kind. Anyway, laughing, rolling my eyes to myself. Okay, so I'm here and I'm going to try to do this problem. It looks like there's a little bit of a typo that got to be a capital X, but I'm sure that they're all lowercase x and there's not 2 x's running around. And so what we're going to do is we want to clear the fraction. So in order to clear the fraction, you have to factor all of the pieces so that you have, so x, all of the denominators. X plus 5 is factored, and you can put parentheses around it to tell yourself did it. X plus 4 is factored, did it. X squared plus 9x plus 20.
Okay. Doesn't have to be right now. Let's give them a chance to weigh in.
Is x plus 5 times x plus 4, right? And so hot diggity dog. So what we're going to do is we're going to have here 2 over x plus 5. I'm going to leave a lot of room. And 3 over x plus 4 equals 2x over x plus 4, x plus 5, x plus 4. And the common denominator, right, says got to have an x plus 5, so we put it. Got to have an x plus 5, got to have an x plus 4, so we put it. Sorry, something's going on in my family and it's distracting me. I'm thinking, what's going on out there? And then here, this trinomial, remember it factored to x plus 5, x plus 4, and it says got to have an x plus 5 and got to have an x plus 4, and we have them, got them. And so, and when I wrote this equation again, so here's the first term, boink, here's the second term, boink, here's the third term, but notice I wrote it in factor form. And now I'm going to multiply every single piece here, both sides of equals, by, I'm going to scoot that over a little bit, by the common denominator. So I'm going to multiply by x plus 5, x plus 4 over 1. And then times here, x plus 5 times x plus 4 over 1. And then times here, I'm going to scoot that equals over because I didn't give myself the right room. So multiplying, notice 3 terms, all 3 terms, x plus 5, x plus 4, over 1. And I'm here to reduce. And what reduces from here is the x plus 5. There's one in the top and there's one in the bottom. And that leaves 2 times x plus 4. And I'm going to need to distribute that, and if you wanted to go ahead and distribute that before writing it down, you could. X plus 4 and x plus 4 leaves 3 times x plus 5. I write the monomial first because that's what I'm used to. And then x plus 5 and x plus 5 and x plus 4 and x plus 4, leaving just 2x on that side. And so I was on, oh, it's got fractions. And the thought is clear them, right? And so we just cleared them. And now my thought is, as I look at it, oh, it looks like it's linear, right? Because when I multiply 2 times x, I don't get x squared. So in fact, let me multiply this together to prove to you that it's just linear. And so how you solve a linear equation is you use the distributive property, which I'm using right now. Then you collect like terms. So 2x and 3x are like terms and make 5x. And 8 and 15 are like terms. And 15, 16, 17, 18, 19, 20, 21, 22, 23. So plus 23 equals 2x. Then you get the variable on one side and the numbers on the other, and there's a variety of ways of doing it. So now I'm on degree 1, linear, right? That's what I'm on solving now, and that's get them separated. And so I'm going to take away 5x from both sides. So I get 23 equals negative 3x, and I'm going to divide by negative 3. So I get, when the dust clears here, x equals negative 23 over 3. That doesn't reduce. And I notice I did not leave myself room to check. And so I've got my scratch piece of paper for my checking. So here I am going to check that. I only have one answer. And so when I go to check, you always check in the original. So this is going to be 2 over, and remember our original was x plus 5. So I'm going to have here plus 5. And plus 3 over plus 4 equals 2x over the x squared plus 9x plus 20. And I'm going to be putting in to all of those spots negative 23 over 3. Okay? And right here too, negative 23 over 3. And 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 it's like, that's a lot of putting in negative 23 over 3. And so I'm going to show you something that you can do to put it in your calculator that I think is helpful. So when I go to put this in my calculator, getting my calculator here, I can put in my calculator, turn it on here, and I'm going to put in negative 23 over 3. And I'm going to hit equals. And so I hit the equal button down here. And that put it down here. So now that's my last answer. And so when I go here to put this in, I can put in my fraction and 2, and then I can go downstairs and I can put parentheses if you like, or you don't have to use the parenthesis, and hit the answer key, because what was the answer? Negative 23 over 3 plus 5. So it just saves me from typing that. And then out to the side, plus, and then fraction 3, and then downstairs, the answer, and the answer key is down there at the bottom, and then plus 4. And so remember what it put in for the answer is negative 23 over 3, our last answer. And so that gives us negative 69 over 44. Negative 69 over 44. Now, if the other side is also equal to negative 69 over 44, then we know that we haven't made any mistakes and we have a good answer. If it's not equal to negative 69 over 44, then we know there's been a mistake. If you just go and use the answer right now, the answer that it'll be putting in is 69 over 44, negative 69 over 44, but I want to put this in. So I have to do that trick again. I have to clear it and put in negative 23 over 3, right? I put it in a little bit differently that time. I put it in as a divide, but you notice when I hit equals, it's exactly what I want. And so now I can put it in as the answer. So 2 times the answer, go downstairs, and the answer squared, and plus 9 times the answer. You don't have to put the parentheses around the answer there, I don't think. And so I don't know why I'm going to put them in, because just what it looks like over there. And so I'm going to get the same, negative 69 over 44. And I'm like, okay, yay, that means it was a good answer. Also, you notice it didn't make any of the denominators of the original 0. This was not 0, this was not 0, and this was not 0. And I do know that I have one where it does make a 0. I'm going to end this video here for part 1 and then come back in part 2 and do 44. I don't know if I'll do all of them or if I'll only do one of them. Knowing me, I'll do all of them. And then 56, because you know how much I love math. And then there's bonus problems there on the back. But I think I'll do those bonus problems in a whole different video. It's getting a lot today. So I'll end that here.